All right, so we're going to do, I'll write this on here. There are 2 worksheets. We'll do the one from page 72. Let's see, 1, 2, or 3, they're all pretty much the same. Let's just do number 1. But watch what it's asking, and I need you to make sure that you read the problems, because it's not like you just see a problem and you're like, oh, okay, that's what I do. You're going to have to read it, because a lot of these problems kind of look the same. They give you different information. They ask for different things. You really, really are going to have to concentrate on this, okay? If you just got by with just looking at a problem and like, oh, yeah, it's one of those, and just write down an answer or whatever, you're not going to be able to do that here. You're really going to have to concentrate. You're really going to have to think. You have to think. And that's why some of you guys are struggling so much with geometry, because in Algebra 1, there wasn't really a whole lot of thinking involved. There really wasn't. I mean, you saw how to do one problem, and what did they do? They gave you a homework assignment, they give you 20 problems, and you do the same thing to every single problem. Geometry is a lot different. Geometry, people struggle with geometry because you have to actually think a little bit on your own. It's not like I just show you how to do a problem and you just do the same thing over and over again. All right, it takes a lot of thinking. So you're really going to have to start training yourself to look at it, to read it, to really understand what the question is asking and what they're telling you and all that kind of stuff. So let's take a look at it. It says find the sum. Let's take a look at that word right now. Find the sum. What does that mean if I'm going to find the sum of something? You got to add up, right? You got to add stuff up, okay? It's the answer to an addition problem, okay? So when it says find the sum of something, you're going to add those things up. So what do you find in the sum of? The sum of the measures of an interior angle. The sum of the, we'll just write it out, of the measures of an interior angle. Now, I did show the video on Monday. You guys watched it, right? Yes? Did your sub show it? Okay, good. Just making sure. And let's do this. Let's just take this one right here. We use this in the other class. This is probably a good picture to use. I just want to I'm not going to go through the whole reasoning why this little formula came out the way it did. I'm just going to show you what it is. So what are they asking for? They're asking for the sum of the measures of, I shouldn't say of an interior, of the, let's put that in there, sorry, of the interior angles. Well, first of all, we talked about interior and exterior angles, didn't we, on the video on Monday? Yes? Which one are the interior angles? The one where? Inside. Very good. Okay, so that one, that one, that one, that one, that one, and that one. Those are all what? The interior angles, right? Now, if I wanted to take all those and add them all up and see what they equal, there's a little formula. Do you remember what that formula was that I taught on Monday via the video? It was a big deal. Well, it's not the number of angles. Well, I guess it could be the number of angles, but you're right. So what letter did we use? It's n. We used n. We said n minus 2. That's actually, the n technically stood for the number of sides, all right? But the number of sides and number of angles are the same anyway. But so it's the number of sides minus 2, and then what did you do to that? Times it by 180. Do you remember we went through that whole process of drawing diagonals? Do you remember that? We drew a quadrilateral, drew a diagonal. We said there was 2 triangles, right? If there's 2 triangles, it's 2 times 180. Then we drew, what? A 5-sided figure, a pentagon. Remember that? And I drew the diagonals to that. There was 3 triangles in there. So what did I do? 3 times 180. Is that ringing a bell at all? Okay. Yeah, that was on the video, right? So that's how I got to it. All right? You have to memorize this, okay? It's important that you memorize this. All right? I don't know what else I can do. This was a very important thing that was taught on Monday. It was on the video, but it was still taught. And I expect you to know this. And I really expect you to know this when you came in here. Because if you didn't know this, you wouldn't be able to do these problems on this worksheet. So this is what we use. What is that n? The n is the number of what? Of sides. Now, Carol said the number of angles, and technically that would be correct. All right, but when we did this, we just said the number of sides. All right, everybody with me so far? So if I wanted to add up all of these angles in here, what would I do? Well, how many sides do I have on this picture right here? This isn't really number 1. This is just this picture right here. What if I had 1, 2, 3, 4, 5? I got 6 sides here, don't I? So how do I find the sum of all the angles inside of this six-sided figure? I use this thing right here. N minus 2 times 180. Well, what's the n? Give me the actual number for this picture. 6. Good. It's 6, right? There's 6 sides. So n is 6. But what do I do with that 6? Minus 2, and then I do what to that? Multiply it by 180, right? Well, what's 6 minus 2? It's 4 times 180. You could put that into a calculator, or you could do it in your head, couldn't you? What's double 180? 360. And if I do another 360, that would be what? 720. Okay, if you can't do that in your head, that's fine. Do it in a calculator if you wanted to, okay? 720 degrees. What did I just find? What is that 720? Is it just that angle right here? It's the sum of all the angles. It's all these angles added up is 720 degrees. Everybody see that? So it's important that you understand what the question is asking. The question says, what is the sum of the measures of the interior angles? It means take this angle, add it to this one, all of them. What are they going to all add up to? 720. Even though I don't know what any of these angles are, do I? I don't know any of the individual angles, but I do know if it's 6 sides and if it's a polygon, I know they're going to add up to be 720 degrees. It doesn't matter what the shape is. As long as I got 6 sides, there's always going to add up to 720. Everybody understand that? Okay. Now, let's take a look at number 1 then. That was just a review of what was taught on Monday. All right, so number 1 says it's 11 gone. All right, that's kind of weird. I don't even think there's a regular name for it. But what does that mean, though? It means there's how many, what? 11 sides. So it just means that there's 11 sides. And, of course, there's going to be 11 angles as well, but we're concerned about the sides. So if I want to find the sum of the interior angles of an 11-sided polygon, what do I do? 11 minus 2, that's right. I put it into the formula, right? It's 11 minus 2, and then what do I do with that? Times it by 180. 11 minus 2 is 9 times 180, and I don't know what that is off the top of my head. I guess I could figure it out, but let's put it in here. So it's 9 times 180, and we get 1620. There it is. Does that look familiar? Yep, that's the answer I read off, isn't it? Pretty simple, isn't it? It's just a matter of throwing it into a formula. That's all you had to do. So 1, 2, and 3 were exactly the same thing. Everybody got that? You just take 2 away from it, multiply it by 180, and then you've got it. I want you, though, to understand what you got. What did you get? What is that 1620? It's the sum of all the angles. That's right. If I took an 11-sided polygon, right, and I drew it, 1, 2, 3, 4, 6, 7, 8, 11. I made 11 sides out of this thing. I don't care what the shape was. It didn't have to be a perfect, you know, all sides, all angles equal or anything like that. If I have 11 sides and I close it all in, I know all the angles, all 11 angles are going to add up to be 1,620 degrees. Do you understand that? Okay. So let's do another one. Let's look at 4, 5, and 6. It says the measure of an interior angle of a regular polygon. Well, first of all, we got to know what a regular polygon is. Let me jump over here. I think I have a nice, maybe I have it over here. Oh, there it is. Let's just do this. I'll use this one. Okay, now we go. Sorry for all the jumping around. Here's a regular polygon. It's not the only regular polygon, but it's one specific regular polygon. Now, we mentioned this before. I think only one person in my other class knew what a regular polygon was. Now, I gave you guys a little hint right there. So if this is a regular polygon, what is true, what is special about a regular polygon? Good. All the sides are equal, and yeah, but we didn't really talk about that, though. That would be true. But all the sides are equal. John said that. And all the angles are equal to each other. That's right. And all the angles are equal to each other. Everybody see that? So if both of those things are true, then it's a regular polygon. If all the sides are equal to each other and all the angles are equal to each other, then it's a regular polygon. Now that's a lot different than that picture I drew up here. Is that a regular polygon? No, because look at this angle right here, and look at this angle right here. They're completely different. This is an acute angle. Well, it looks a little. This one right here, that's an acute angle, and that's an obtuse angle. Is there any way this is a regular polygon? No, not at all. Okay, but this one right here is a regular polygon because all the sides are equal and all the angles are equal. You with me on that? Okay, so now we know what a regular polygon is. Let's go a step further. Now, they're going to ask for each interior angle. Now, there's a way to do that. There's two ways to do it. But I'm going to show you what I think is the easiest way to do it. Okay, I'm not even going to show you the other way. All right, I think this is the easiest way. Now, even though it asks, they tell you the measure of each angle, all right? And they ask you to find out how many sides are in the polygon. But I want to talk about this for a second. Look at this. What kind of angle is this thing right here? Is it interior or exterior? That's interior. Why? Because it's inside the polygon. But if I took one of the sides and extended it out, what's true about this angle right here? This would be called an exterior angle, right? Why? Because it's outside the polygon. Now, go ahead, John. You saw it. What do you do if you add those two together? They add up to 180, don't they? All right. But there's something else about the exterior angle. This angle right here is our exterior angle. We just figured out up here how to find the sum of the interior angles, right? We added up all the interior angles, but we had to use a little formula, didn't we? We used a little formula to find how much all the interior angles added up to be. But there's really no formula to find the sum of the exterior angles. Do you remember in that lesson? The sum of the exterior angles. Is there a little formula for that? No, there's not. Because why? Because it's always equal to 360 degrees. You guys remember learning that the other day? It was Monday, but you did have a worksheet on it, so you should have looked back on it if you didn't quite get it on Monday. I put it up on YouTube. Okay, it's under your class. If you go to the playlist, it's under your class. It's all on there. So the sum of the exterior angles is always equal to 360 degrees. Okay, it doesn't matter how many sides you have. You can have 3, 4, 5, 6, 7, 8, 9, 10. Doesn't matter. 1,000 sides. If I add up all the exterior angles, watch. If I took this angle right here, and if I added it to this angle, and to that exterior, sorry. I'll try to make these look kind of straight. Okay, if I extended this side, I extended this side, and I extended this side. Everybody see this? Look, if I added up this exterior to this one, to this one, to this one, and to this one, guess what all 5 of those are going to add up to be? 360 degrees. I could do that with a 10-sided figure. I could do that with a 100-sided figure. And they're still, the exterior angles will always add up to 360 degrees. That's pretty interesting, don't you think? I do. I think it's pretty cool because no matter how many sides you have, the exterior angles will always add up to the same exact number. Will always add up to 360 degrees. All right? That's really important. So, what's important about this problem on 3, 4, and 5, or what is it? 4, 5, and 6? First of all, you need to know what it means to be a regular polygon, and you need to know what the sum of the exterior angles are equal to. Okay? If you know those two things, you might be able to figure out this problem. So let's get rid of that. And what I'm going to do here, remember, we don't know how many sides this thing has. So I can't draw like a 5-sided, 6-sided, 7-sided figure because I don't know how many sides they have. But I'm going to do this. Let's just do like a little bit of a polygon. I'm just going to draw one about like that. Is that okay? Now, I don't know how many sides. I could keep on going. I don't know if there's 100 sides. I don't know if there's 10 sides. I don't know if there's 7 sides. I don't know. All right, so I'm just going to kind of leave it open right here. But what do they tell me? It says the measure of an interior angle is given. So look at number 4. This is number 4. They say it's 144 degrees. So that says this interior angle, they tell me it's 144 degrees. Okay, but what am I trying to find? I'm trying to find out how many sides there are on this polygon. I left it open because I didn't know how many sides there were. Everybody get that? Yeah. Okay, that's why it's not completed. All right, but I do know that this angle is 144. And it says it's a regular polygon. Exactly. This is a regular polygon, so this side, this side, this side, and all the other sides are all equal, and all the angles are equal, right? Okay. So if this is 144, Anthony, you were saying it earlier. What am I going to do? Right. 180 minus 144. Now, why would I want to do that? Because that's going to give me the exterior angle. And why do I care about the exterior angle? Because it makes things a lot easier for me. And I'll show you why. So if this is 144, how do I figure that out? It's 180 minus 144. And that's what? 36? Okay, so that's 36 degrees. Everybody with me so far? Now watch this. If this is 36 degrees, remember what's true about the exterior angles? Well, it's a regular polygon, so they're all 36. I could keep on doing this for as many sides as I have, right? So if they all add up to 360, and each of those exterior angles was 36 degrees, everybody watching? Everybody paying attention? Come on, let's think. So I gave the example in class to this. Usually people are more interested in money than angles and stuff like that. So let's say this. Let's say I had $360. Okay, now you're thinking. Now I don't. I wish I did. I don't think I ever have $360 in my pocket unless it's for some other reason. Let's say I had $360 and I wanted to give it out, right? But I wanted to give it out in $36 increments. Okay, so I've got $360. So I'm going to give Georgie 36, and I'm going to give Anthony 36, and down the line, okay, until I've given out all my money. How do I figure out how many people get $36? I divide, right? I take the money that I had, $360, and I divide it by what? 36. And that's going to tell me how many people get the $36. Isn't that the same exact thing with the angles? If you can picture that with with the money, okay, the same thing holds true with the angles. Look, I got 360 degrees all together because they all add up to 360 degrees. Each one of those angles is 36 degrees. So guess what I do? I divide. And what's 360 divided by 36? It's 10. So how many sides does my polygon have? It's got 10 sides. Does that make sense? All right, but what did I have to do? They gave me the interior. I had to figure out what the exterior was. Once I figured out the exterior, then it was a piece of cake. Then I went 360 divided by 36, and I got how many sides I have. You got it? I mean, technically, this tells me how many angles there are, but there's just as many angles as there are sides. So if there's 10 angles, there must be what? 10 sides. Make sense? So you should be able to do 4, 5, and 6 now, and it's like this. But you got to be careful. You got to read the instructions, very, very carefully, and know what they're giving and know what you're trying to figure out. Because if you look at 1, 2, and 3, and you look at 4, 5, and 6, they almost look like the same type of problem, but they're really not. They're asking for something completely different. All right, so make sure that you read it. Okay, enough of that. Let's move on. Let's take a look at 7 and 8. Let's just do one of these. Which one? Do you have a preference? 7? All right, let's do 7. I heard 7 first, so we'll do 7. I don't think one's any easier or harder than the other one. All right, looks kind of like that. Probably a little longer than it needs to be, but that's x degrees. Can't see. That's x plus 15. And this top one is 2x plus 15. 3x minus 20. Okay. Alright, so here we go. Look at this thing right here. We're trying to find, it says find the measure of each interior angle. So we're not just solving for x, are we? We want to find out what each of these angles are equal to. Everybody with me? So what do we do? Do we set anything equal to each other? Do I know that this is equal to this? Are they all equal to each other? No, but they do add up to something, though. That's right. They add up to 360. Now, how in the world did you get 360? There's 4 sides, right? So how do you figure out what all the angles add up to be? The sum of all the angles. It's 4 minus 2 times 180, right? How do we get that 4 minus 2? Well, that was from that. Oops, not an M.
So we already know this. We have to show the question for that. We
Yeah, on a four-sided figure, that would be easy, right? You should be able to. You should know that off the top of your head. A four-sided figure is 360. Okay, but I'm just doing it so that everybody knows where we got that number from. 4 minus 2 is what? 2 times 180, and that is what? 360. Now, it's not. Even though it's 360, that really doesn't have anything to do with the exterior angles, does it? Okay, but what's true about what happens to all four of these angles? We add them all up. That's right. We add them all up, and what do they equal when we add them all up? 360. Does that make sense? So let's do that. So I'm going to write it out. So the first angle up top here is 2x plus 15. We'll go around the horn here. So that's 3x minus 20, and that's plus what? X plus this one right here, which is x plus 15. See what I just did? I took all four of those angles, I added them up, and I set them equal to what? 360. Yeah, so let's do it. Let's add up the like terms. Let's add up all the x's. 2x plus 3x is 5x, plus 1 is 6, plus another one is 7. So that's 7x. Let's add up the regular numbers. 15 minus 20 is negative 5, plus 15 is positive 10. Right? Got them all, I think. And that equals 360. Right? It's just basic algebra 1 at this point, isn't it? Subtract 10 from both sides. So 7x equals what? 350. Divide by 7. And so what's that? 50, right? So x is 50. Do I circle that? Is that my answer? No, because they're not asking you to solve for x, even though you had to. Just plug it back in. Right. Plug and chug. Put it back in. Let's do this. We can do this in our head. What's 2 times 50? It's 100, right. Plus 15 is 115. Good. What about this one? 3 times 50 is 150. What's 150 minus 20? 130. So that angle's 130. Now this is just x. So that's just 50, isn't it? This is x plus 15, or 50 plus 15, which is 65. And there you go. Put little degree symbols because they're degrees. That's your answer right there in blue. It's not so bad, is it? Okay. They could give you a figure that's not 4 sides, but maybe 6 sides or 7 or 8 sides. Well, what would you do to figure out that? Do the same formula, right? N minus 2. What if it was 8-sided figure? I go 8 minus 2, which is 6 times 180, whatever that is, and then I would add up all 6 angles, or I'm sorry, all 8 angles, set it equal to whatever that number was, and I'm good to go. Alright? Alright, the next part's a little bit confusing. It's probably the most confusing out of all of them. Again, because it kind of looks like that, those first 6 problems, but they're giving you different information, and they're asking you to give different information for your answer. So let's read it. Let's be very careful. Let's read it so we know what they're giving us and what we're trying to figure out. It says, find the measures of an exterior angle and an interior angle. All right? So let's think about it. Before I do anything else, here's my polygon. Right? Looks something like that. Remember before? And what am I trying to find? I'm trying to find 2 things. I'm trying to find the interior angle, and I'm also trying to find what? The exterior angle, right? So if I find one, what do I do to find the other one? That's right. So look, if I can find the exterior angle, I just take it away from 180 and I've got the interior. Or the other way around. If I can find the interior, then I take that away from 180 and I got the exterior. Everybody see that? Because the exterior and the interior make a straight line, don't they? And so they have to add up to 180. So what are they giving us? It says, given the number of sides of each regular polygon. So they don't even tell me one of the angles. They tell me how many sides I have. All right? So they're going to give me the number of sides. So they tell me, let's do let's do one that comes out even. Let's do number 10. Just to make this a little easier for us. Okay, so we're going to do number 10. And by number 10, they put 24. So what are they telling me? What information is this problem giving me? 24 what? There's 24 sides. That's right. So I got to figure out, if they tell me there's 24 sides, I got to figure out either the exterior angle or what else? The interior angle. Do I have a formula for either one of those? Yeah, absolutely. Remember that? N minus 2 times 180? What is that N? It's what? It's the number of sides, isn't it? Okay, and what do they give me? They give me the number of sides, don't they? So it's perfect, isn't it, to use this thing right here. So let's do that. Problem is, what am I finding when I'm doing this? I'm finding the sum of all the angles. But I need to find just what? Just one of the angles, right? We'll talk about that in a second, but let's do this. Let's find the sum first. N minus 2. So it's 24 minus 2. Yeah, and I know you can do that in your head. I'm just writing it down, though, so that when you look back on this and you look in your notes, you know where you got that 22 from. So 24 minus 2 is 22 times 180. And I don't know what that is off the top of my head, so let's put it in the calculator. 22 times 180, and that's 3960. Okay? Well, what's that 3960? Is that angle right there? No, it's not that angle. That's the what? That's the sum of all the angles. What if I want to find just this angle right here? That's right, divide by how many sides I have. Because it does say, I didn't say this, but it does say that it's a regular polygon. Okay? So that means all the sides are equal, right? All the angles are equal. So if I take 3960, watch this. If I take 3960 divided by how many angles I have, how many angles do I have? 24, right? Don't use the 22. You're using 24, okay? So divided by 24. Again, I have no idea what that is. 3960 divided by 24, and that's 165, okay? So that's 165. What did I just find? I found each interior angle, didn't I? Got tons of arrows. I shouldn't have all these arrows. Let's get rid of some of these. All right, so this angle right here is 165 degrees. I'll just put it here. Everybody see what we did? We did the sum, then we divided by how many sides we had, and that's this interior angle. Then how do I find the exterior angle if I know the interior? Take it away from 180, that's right. So it's 180 minus 165, and that's 15. So this angle right here would be 15 degrees. Okay. Do you have to draw out a 24-sided figure to be able to do this? Absolutely not. That would be a waste of time. Look what I did. Don't you like how I did this? Just did a little bit of it, right? You don't have to do the whole thing. I just did a little bit of it so that I could see the interior angle and I can see the exterior angle. Sometimes the picture is very helpful to you. Right? It kind of keeps track of what you're finding without doing all this math stuff. Don't just try to memorize a bunch of steps. Know what you're actually finding and why you found it that way. Absolutely. That's even a better way, isn't it? Yeah, I thought about doing that, and I should have. But look at this. If there's 24 sides, how many angles are there? If there's 24 sides, how many angles are there? There's 24 angles, right? Okay. So watch this. If 24 angles add up to 360, how do I find each angle? That's right. 360 divided by 24. And you're absolutely right. I was thinking about doing that, and I don't know why I didn't. But I'm glad you brought that up. Because this is a little easier. What do? 360 what? Divided by 24. Now, what am I finding here? That's the exterior angle, isn't it? Do you see that? Because all the exterior angles add up to 360, divided it by 24 because there's 24 exterior angles, and that gives me 15. So each one of these angles is 15 degrees. It's like this. If we had 24 people in this room, right, and I said, okay, I got $360. I want to distribute it evenly between everybody, all 24 people, right? Each person gets what? $15. You get it? Now, what's this going to be? 180 minus 15, which of course is still 165. I still get the answer the same exact way, don't I? All right. So there's two ways to look at this, and John, I like your way better. It's not really your way, but it's the way that you suggested. Okay. So that's a good way to do it. To find the exterior angle first, then take it away from 180. You got the interior. It saves you probably a step. All right. And anything that saves a step, I'm for. Okay. And that pretty much covers. You do the same thing from 9 to 14. You do the exact same thing, so you should be able to figure those out. All right. So tomorrow we're going to do this. We're going to do the same thing, but we're going to do 6-2. Now you had two things on 6-2, didn't you? You had a worksheet and you had stuff from the book. All right. So have both of those tomorrow, ready to turn in tomorrow, because we're going to go over those tomorrow. And then on Wednesday we're going to start 6-3. Okay. We're going to move on and start the rest of the chapter on Wednesday. Everybody okay with that? I do want 6-1 though, so make sure you pass 6-1 up. Make sure your name is on it, and I shall take those.